if you want to plot y equal to mod of f of mod of x, or if you want to plot mod of y equal to mod of f of x, and these graphs are really interesting, I'm telling you, then you need to watch the full video, watch till the end, then your answer will be. And still, if you haven't subscribed my channel Physics in My Way, then please consider subscribing by pressing the red button. Hello guys, welcome to the part 2 of this video of plotting graphs. So in this video I'll be completing the rest of the part that I have not discussed in the part 1 video. And still, if you haven't watched the part 1 video, then please watch the part 1 video. The link should be coming here in the I button. And one more announcement. So I have done some silly mistake in the part 1 video. So while discussing the mirror image, I have written if fx is like x to the power n, then you can plot g of x as if g of x are in the form x to the power 1 by n. So previously I have written as 1 by x to the power n. So these things you need to correct. And one more detailed thing about when I was plotting sine of x square, then you need to consider that it is obviously a even function. Then you need to plot symmetrical image about the y-axis. So the graph will be looking like this. The frequency will vary and this will be like this. So this region I have done a mistake here. So you need to correct this thing. So thank you guys for mentioning this part. So without wasting much time, let's just jump into the video. Starting with a basic function, let's say if you have given a function f(x) equal to a to the power x, I will consider two cases where if a is greater than 1, and in the second case if a lies between the 0 and 1. For the first case, so how will be the graph for f(x) equal to a to the power x when a greater than 1? Now as you can see, it goes on increasing from 0 to say infinite. Then you can see for a to the power 0 it will start from 1, and slowly as x will diverge, then the function will also diverge. So it will go like this. Now for the negative part of the region, if x is less than 0, then the function will goes on decreasing and it will tends to 0 when x tends to minus infinite. So it's a simple graph as you can see. Now case 2, when a lies between 0 and 1, then the graph will be exactly the mirror image of this graph, and the mirror of plane will be the y-axis. So just the inverse of this graph. So this is for the case 2 and this one is for case 1. Okay, so it is very much simple. Say some simple function exponential of x, then this will be similar looking like f(x) equal to a to the power x for the case a greater than 1, because e has a value 2.7 what in something. So it means it is greater than 1. So the graph will be exactly similar for the a to the power x graph. So here is the 1 point. So this is the graph for e to the power x. Now for e to the power minus x, the graph will be exactly mirror image of this graph e to the power x. So it will look like this. So the function will be dying to 0 as x tends to infinite, and it will diverge for values x less than 0. So as simple as that. This is the basic exponential function. You must be knowing all these graphs. Now let's get into deeper. Now if you have given a function f(x) equal to e to the power minus of x square, then obviously it is a even function. So when the function is even, then you know that the graph will be symmetric about y-axis. So this is y and this is x-axis. Then the function will be looking like this. This is a Gaussian distribution function, you can say. So this is e to the power 0, starts from 1. So when ax is going to plus infinite, then e to the power minus infinite, that is 0. Or if x goes to minus infinite, then this function will slowly dies out to 0 when x tends to infinite. So this is as simple as that. Equal to e to the power x square, then it will also be exactly mirror image of e to the power minus x, provided the mirror of plane will be at y equal to 1. So it is a line y equal to 1. So the graphs will be looking like this, just the opposite case in the page, then e to the power minus x square. So here, as you can see, as x tends to infinite or plus infinite, the function will diverge to infinite also, rather than going to equal to e to the power minus of x square. Obviously this is an odd function, so it should be anti-symmetric about the y-axis. Now let us plot the function, how it is looking like. So it should look like for the positive region, so it will start from 0 when x equal to 0, obviously the function is 0. Now if x goes on increasing, then it will look like this. So it will have a maxima at certain point, you can find out, and slowly it will die out to 0 when x tends to infinite. Now as this is an odd function, then for the negative axis, so it will be anti-symmetric, so the function will look like this. So this is well known fast excited state of the simple harmonic oscillator. So physics guys knows this trigonometric inverse function, that is, let's say if your function is y equal to sine inverse x or cos inverse x or tan inverse x or any other inverse function, this trigonometric function, then the key thing is all these graphs will look like sin x, cos x or tan x, provided the mirror of plane will be y equal to x axis. So it will be mirror image for sin inverse x, it will be mirror image of sin x about y equal to x axis. So let us plot that. So for sin x, the normal sin x graph is like this. Now I have said that this will be a mirror image about the y equal to x axis. So let's say this is y equal to x, then mirror image of this will look like, so this is your sin inverse x. We can see the mirror image of this portion is here. Okay, so similarly think of the mirror, it can show image this region also in this region, then it will be exactly mirror image of this curve in the y-axis. Or similarly you can also write from here that x equal to sine of y, then the variation of sine function will be about the y-axis. So you can also think in that way. Cos inverse x, you can also easily plot that cos x graphs look like this. So it oscillates between +1 and -1. Now if you have a y equal to x axis, say about this, then your cos inverse x graph will look like this. So it will oscillate between +1 and -1. So you can say it is mirror image about y equal to x of the graph cos of x, or easily you can write x equal to cos of y, so this cos value part will be in the y axis. And inverse of x, then similarly it will be mirror image about the y equal to x axis. So your normal tan inverse x graphs look like this, sorry tan x, then your tan inverse x graph will look like this, as done in the red line. So your y equal to x line is here. So as you can see, it is exactly mirror image about the y equal to x axis. So this is the simplest way of plotting the inverse function of this trigonometric function, modulus of function or absolute valued function. So for this you need to know that the function will have only positive values. So let's say if you want to plot f(x) equal to mod of x, then you know that y equal to x, the curves looks like this. So this is the curve for f(x) equal to x or y equal to x. Now when you put modulus of that function, if you want to take the modulus of the function, then the only thing that all the negative values of the function will be shifted to the positive region. So the graph will be look like this. So this is the modulus function, and obviously it is also the even function, so it is obviously symmetric about the y-axis. So you need to know, you just need to shift all the negative values of the function to the positive side, that's all. Now if you want to plot on this same graph, now plotting mod of x plus of 2 or mod of x minus 2 on the same graph, then obviously this origin will be shifted towards the, or it will be incremented by 2. Then this is your graph for x plus 2. and similarly for x minus 2, then this origin will be shifted to our origin which is starting from minus 2. So this is the only thing you need to consider. So this is for modulus of ax minus 2. So this is the mod function. Now this is going to be the most interesting part of this video, how to plot graph using mirror image concept or rotation about 180 degree about the y-axis. So let us give some example. If you have plotted the graph for exponential of x, then I have discussed that the graph will look like this. So this is e to the power x. Now if you want to plot e to the power minus of x, so that is if you know a graph for a function f of x, then you can easily plot for the graph of f of minus of x. All you need to do is rotate the whole graph for fx about 180 degree about the y-axis. So for e to the power minus x graph will look like this. So as you can see that as if I have rotated this graph about 180 degree throughout the y-axis. So this is for e to the power 1 e to the power minus x. So any this type of function where x is going to minus of x, you can easily plot by using mirror image. I will show more example, log of x and log of minus of x. Then as you know, log of x function, log of 1 is 0 at x equal to 1, and it will diverge slowly to the infinite when x tends to infinite, and it will die out to 0. Sorry, it is die out to infinite about the y-axis for x tends to 0. So x tends to infinite, the function slowly going to infinite, and x tends to 0, the function also going to negative infinite. Okay, so this is the graph for log of x. And if you want to plot the graph for log of minus of x, all you need to invert this about 180 degree about the y-axis, or you need to flip this graph. So this is a mirror image about y-axis. So it should be exactly mirror image about the y-axis. You need to maintain this symmetry. Okay, so this is the graph for log of minus of x. Inverse of x, then if you want to plot sine inverse of minus x, then it will be exactly mirror image of sine inverse of x about the y-axis. Or you can think as if you have rotated it 180 degree about the y-axis. So this is the graph for sine inverse of minus x, and this is for sine inverse of x. So there are many more examples of how to realize this mirror image when x going to minus x. But this mirror image will be drawn about the x-axis, or you can say, you can imagine the graph to be rotated 180 degree about the x-axis. So when you want to plot a function fx, you know the function, and you want to plot minus of fx, then all you need to do is invert your image about the x-axis. So the mirror image will be inverted about the x-axis. So now if you have plotted the e to the power x graph, which is looking like this, then your minus of exponential of x should be looking like this. So as if the mirror is about the x-axis, or you can say you have just flipped 180 degree about the x-axis. So this way you can realize how to plot when fx goes to minus of f. Interesting this part. So when your fx goes to f of mod of x, so instead of the whole modulus of the function, you are taking the modulus only of that on those variables which it consists of. So it follows two rules. So the first thing is, leave the graph right side of the y-axis as it is. So whatever in the right axis of the right side of the y-axis, you will leave all those part as it is, and take image of fx for whatever lying in right side of y-axis. So whatever in the right side of the y-axis, so you should take a image of this about y-axis in the left side. So in scar for whatever for x less than 0, and take the image for x greater than equal to 0 in the right side of the graph. So all you need to do is, so you need to neglect this x less than 0 part, and you need to take image whatever that is lying on the right side. So your graph will look like this. So the resultant graph of final f of mod of x will look like this. So right, so it should be exactly symmetric. So whatever in the right side, I have taken an image in the left side about the y-axis, and whatever remaining for x less than 0 in the function, that I will omit. So this part I have omitted. So this is the final graph for f mod of x. So if f(x) is a function which is a function of individual modulus of those variables, then the graph will look like this. So this is the generalized rule of how to plot if f(x) goes to f of mod of. So here is the generalized thumb rule I have already discussed. So for more example, if you take, then it will be much more clear. So if you have graph for log x, so you know the graph for log of x. Then if you want to plot graph for log of mod x, then I have said the whole graph will look like this. So here nothing in the negative side of the x-axis. So all you need to do, image of this right side, whatever it is, right side of the y-axis. So the resultant graph will look like this. So this whole graph is for log of x. So it will have this region and also have this left side region. Now taking more example, if you have the function for exponential x, so then it is like this. So if you want to plot exponential of mod x, then all you need to do, whatever in the left side of x-axis, you need to omit this. So you will omit this part, okay, and you will take image whatever lying in the right side of the y-axis. So the final graph will look like this. So this is the final graph containing this left side part and also this right side part. So this is the graph for exponential of mod of x. So this way you can easily plot where f(x) transforms to f of mod of x. There are many more examples. You can take whatever plot a function which is like this. Let's say mod of y equal to mod of f of x. So both sides it has a modulus. Then how to plot this function? So let us just understand with a example. Let's say you have asked to plot e to the power x of -1 and then modulus. Then you need to plot. So you need to know e to the power -x -1. So it will be look like this. So it will exactly go through the origin. Okay. So because previously e to the power x was going like this, in this case it will go through the origin. Okay. Now you need to plot mod of y, mod of e to the power x -1. So the step 2 is first plot e to the power x -1. So modulus of e to the power x -1. How to do that? I have already told. For taking the modulus of the function, all you need to consider the positive zone. So whatever in the negative part of the graph, that you need to shift to the positive zone. How? So positive part will remain as same like this. So this negative part, this part, it will be inverted to the positive side, taking x-axis as the plane of mirror. So I will take mirror image of this portion about x-axis. So the graph will look like this. Okay. So this is a graph for mod of, okay, so mod of e to the power x minus of 1. Now the final part. So now if you want to plot modulus y equal to mod of e to the power -1 whole mod of that. So this is the function for mod of e to the power x -1 plot. So plotting, so if you have modulus in the left hand side, then all you need to do the whole mirror image of this graph. So I have the graph like this, then I will take the mirror image of this whole region. So the graph will look like this. This and this. So this whole graph, which consists of this line and also this line, line 1 and line 2. So this whole graph belongs to the curve mod of y equal to mod of e to the power x minus 1. Okay. So it is very much interesting. So you can plot many more functions. If you want to do experiments with other function, then your concept will be much more clear. Okay. Now how to plot if a function goes to modulus of f of mod of x. That means the individual variable are in the modulus form, and then we are taking the modulus of the whole function. So for plotting this kind of graph, you need to follow 2 steps. So step 1 is, first you need to visualize the graph for mod of fx. I have already discussed how to plot mod of fx if fx is known. So how you can plot? So all you need to do is, whatever in the negative side in the y-axis, that will be converted to the positive side of the y-axis, taking x-axis as the mirror of plane. How? Let's say if you have a function which is varying like this, so the function is varying like this way, then all you need to do, you take a mirror about x-axis. Then only this negative part will be get inverted by this mirror in the positive zone of the y-axis. So this is the graph for f of mod of x. Sorry, mod of f of x. So the function will have no negative values, only have positive values. So this is the step 1. Still we need to do the step 2. Now, so we have got from step 1 that the negative part will be converted to the positive part of the y-axis, taking x-axis as the mirror of plane. Now for the final part, that is mod of function of mod of x. Okay, so for this part I have just already told sometimes ago that if the variable are in the modulus form, all you need to know, so whatever in the function, that is here in the previous function, whatever in the function in the negative of the x-axis, that you will neglect, and then you will take mirror image about the y-axis. So after performing step 2, your graph will look like this. So first part is, I will neglect this part, so I will delete this part, so the graph will be like this. Then what I will do, then I will draw the mirror image about y-axis. Okay, so whatever in the right side of the y-axis, that will be inverted 180 degree by this mirror about y-axis. Then the final graph will look like this. So this is the way how you can plot the function. If you know fx, then you can plot mod of fx. Then following step 2, you can also plot mod of f of mod of x. So this is the generalized way. You can take any known function, you can plot modulus of the function, and you can reach this final step. I will discuss some more example, then it will be much more clear. Now say, let's say you have a function y equal to x square minus 2x minus 3, and then you want to plot y equal to mod of x square minus 2 into mod of x minus 3. So the first step you need to do, first you can plot y equal to mod of x square minus 2 of mod of x minus 3. So y of x looks like this when there is no modulus. Then if you want to plot for this function, then I have told that for if the variables are in the modulus form, all you need to do is, you need to neglect whatever in the negative side of the x-axis. So you will neglect this part, and then you will take mirror image about y-axis for whatever the part are in the right side of y-axis. So right side of y-axis, it was like this. Here is a plus 3 point. You can know this point by solving these equations, or where the function dies out. Then you need to take the mirror image of this curve. So this will be look like this, and this is minus 3. So this is the graph for y equal to mod of x square minus 2x minus 3. So here I am following the step 2 than the previous case. Okay, you can follow step 1 and step 2 as you can wish. Now you can go to y equal to modulus of mod of x square minus 2 of mod x, and then minus of 3. So how you can do that? So all you need to do, whatever in the negative side of the y-axis, you will shift to the positive side. So means this part will be inverted, or will take mirror image of this part about the x-axis. So the final graph will look like this. So this part will be there, so this is this part, and this below the negative region of the y-axis, so this will be inverted about x-axis, so like this. So this is the final graph for this function. Okay, so it is very much useful to use the mirror concept, mirror image concept. You can easily plot this modulus of the function. You can plot much more function as you like. Then you will find the real fun of plotting all these graphs. Well, I had a really good time of plotting all these graphs, and I hope I have shared some information with you that will be valuable for you. So, and also enhance your concept of plotting graphs. So let me know in the comment section what do you feel about this video, and if you like this video then just smash that like button and subscribe to my channel for any future video that I will upload very soon. So that's for it today. I will come back with another new video that will be much more useful for your interviews or in your understanding of physics. So I will be back very soon. Till then, bye bye.